Hey guys, so this is Robert Peltikov, and today we're going to be going over number 52 from Chapter 3 in the Physics C book textbook, Physics for Scientists and Engineers. So, this problem gives us a vector called r that is defined by 2I hat, j hat, plus 3k hat. Alright, now let's do number A, which asks for the magnitude of the x, y, and z components. So let's start with what we're given. So we're given the r vector, which is equal to the 2I hat plus j hat plus 3k hat, right? And from this we can also write it in another way, saying that r is equal to the rx magnitude times I hat, which is a unit vector in the x direction, ry magnitude times the j hat, no mistake, ry magnitude times j hat times the rz magnitude times the k hat. And this way it's pretty easy to see that the x magnitude, the y magnitude, and the z magnitude would be equal to the magnitude of the x direction, which is 2, the magnitude of the y direction, which is 1, and the magnitude of the z direction, which is 3. Now in part B, we are asked to find the magnitude of the r vector, which is known as r within two of these absolute value signs, or just r without the vector hat, and that is equal to the square root of the sum of the square of the x magnitude, the y magnitude, and the z magnitude. Now we just substitute in those values, so that would be 2 squared plus 1 squared plus 3 squared. And notice we don't have any units on these because they are all scalar values. Just wanted to reiterate that. That's 4 plus 1 plus 9, which is then root 14. And now for part C, we're asked to find the angle between vector r and the three axes, the x-axis, the y-axis, and the z-axis. And so to do that, let's write out some formulas. We have cosine of theta, which is the angle between two vectors, is equal to u vector times v vector, or dot product v vector, all over the multiple of the magnitudes of those two vectors. In other words, we can rewrite this as theta is equal to inverse cosine times of u dot v under their, all over their magnitudes, right? And lastly, the dot product we can write out to be u dot v is equal to, that's what's equal to the magnitude of u times the magnitude of v in the x direction, plus the y magnitude of u times the y magnitude of v, plus u magnitude of z times v magnitude of z. So those are the three equations we need. Now to actually do the first thing that part C asks for, we have our equation theta is equal to inverse cosine u dot v over their magnitudes multiplied. And so we start. We want to find the angle between r and the x-axis. So the x-axis we can denote as a unit vector in its direction, which will be equal to I hat, right, because that's a unit vector, plus 0 j hat because there's nothing in the y, and 0 k hat because there's nothing in the x, in the z direction. And then we can just plug into our equation. So then we have inverse cosine of 2 times, or actually let's start simpler than that. So it will be inverse cosine of the magnitude of the x direction of r times the magnitude of the x direction of our x unit vector, plus that in the y direction, plus the multiple in the z direction. And that's going to be all over their magnitudes multiplied. So rx. We can now start substituting into that and go inverse cosine is equal to 2 times 1 plus 1 times 0 because the has no magnitude in the y and the z. And that's going to be all over the magnitude. So r would be root 14 and x would be just 1 because it's a unit vector. So 1 times root 14 as we figured out in the last part. And simplify this even more. Cosine inverse of 2 over root 14, and that gives us an angle of 57.7 degrees. Alright, and now we get to do the same thing with the y-axis. So we will label our y unit vector as y to be equal to 0 I want it focused, plus 1j plus 0 k hat. And we know that y's magnitude is a unit vector, so its magnitude is just 1. And so then we can actually start plugging into our formula. So theta is equal to inverse cosine of their dot product, which is going to be r magnitude x times y magnitude in the x plus r magnitude in the y plus y magnitude of the y, and r magnitude of the z direction plus times y magnitude of the z direction, all over the multiplication, the multiple of their magnitudes. And then we simplify into this, so this will be the x magnitude of r, which is 2 times 0 of y, the y magnitude of r, which is 1 times 1, and 1 of magnitude of y in the y direction, plus 3 times 0, because there is no z direction of the y vector. And then their magnitudes, y is 1 unit, and that is times root 14, which is that of r. So then we simplify, we have inverse cosine of 1 over root 14, which is about equal to 74.5 degrees. And you have that with the y-axis. And then we get to do it with the z-axis. And for the z, we do the same thing all over again. We label our z vector, which is going to be equal to 0. We have 0 I hat plus 0 j hat plus 1 k hat. And then the magnitude of the z vector is just 1. And then we will start plugging into our formula once again. So that theta, the angle between r and z vectors, will be inverse cosine of the magnitude of in the x direction of r times z plus the magnitude in the y direction of r times z plus the magnitudes of r and z in the z direction. And that will be all over their complete magnitudes multiplied by each other. And then we have substitution, so that's 2 times 0 plus 1 times 0 plus 3 times 1. And that will be all over root 14 times the magnitude of the z direction of z vector, which is 1. Simplified, that's inverse cosine of 3 over root 14, which then is approximately 36.7 degrees. And that's the last problem. So that was number 52 from the Physics C book for scientists and engineers, version 7, chapter 3. and hope you guys understood the problem, got it, have no questions left. If you do, leave it in the comment section below. And we'll see you for chapter 4. Thank you very much.